Okay, let's get started. The topic of today's video is going to be fundamental physical quantities and unit conversion. And it's a fairly important topic in physics because, as you might already know, in physics we always deal with physical quantities, namely quantities that exist in the real world, and therefore we have to be careful how we define these quantities and the units that we assign to them. And the units matter because they give us a scale of the system we're studying. So in classical mechanics, which is the topic of this first series, all the quantities that we will study can be derived from three fundamental quantities. These three fundamental quantities are length, time, and mass. So any other quantity, such as speed, force, acceleration, work, power, and so on and so forth, can be derived from these three quantities here. Now, as I just mentioned, to each quantity, it is important that we assign the units because the units tell us a scale of the magnitude of the quantity that we're studying. So, for instance, you can see the need for units if I say, yesterday I worked 3, and if I'm discussing time, but I don't give a unit to that number, that phrase right there is meaningless. Even in just good old English, you would ask me 3 what? 3 hours, 3 minutes, 3 seconds? Because the unit that we assign to it makes a difference. Now, there are different ways of defining the units for these quantities, but in this course, we will choose to work in the so-called SI system of units. SI stands for International System of Units. And as you will see, this is the system that makes the most sense because it's based on powers of 10. And in this system of units, the units of length is the meter, denoted by m. The units of time is the second. And the unit of mass is the kilogram. Now we're all familiar with the second. To give you an idea of the scales that we're discussing here, the meter is more or less a yard. And the kilogram is equivalent to roughly 2 pounds of weight. You'll see later on why I make this distinction between mass and weight. Now these things have definitions, but we don't need to worry about how they're defined for now. Maybe we'll discuss it later on. All we need to know for now is that in the system of units that we use, these are the standard units for each of these fundamental quantities. Now, I should mention that there's also the so-called British system, which is the system of units we use in the US. But we will try to avoid the British system as much as possible because, in my opinion, and I hope no one takes this personally, the British system is a very primitive way of defining units. So to give you an example, if we talk about length or distance, in the British system we have the inches, and then we have 12 inches in a foot, but we have 3 feet in a yard. And if I remember correctly, we have roughly 1,670 yards in a mile, or 5,280 feet, but it doesn't matter. But as you can see, it's already very difficult to remember these things, and because we don't want to remember anything or try to memorize anything in science, we'll try to work with a simpler system of units, which is, for our purpose, the SI system of units. Now, sometimes the quantity that we're working with is not already in the desired units, and in that case, we must convert. So, for instance, we might have a measurement of length, which is in millimeters, and for our calculation, we need that length in meters. So we need to know how to convert that. And one way of thinking of a conversion of units is as a currency exchange. The conversion itself does not change the value of the quantity, but merely the way we express it. So if I have $10 in my pocket, I can say I have $10, but if I'm talking to someone from Italy and they don't know how much a dollar is, if I know the conversion factor, namely the currency exchange rate between dollars and euros, I can tell them I have roughly 9 euros in my pocket, and they'll know what I mean. That being said, Expressing in a new quantity, in a new unit, does not change the value of the quantity itself. The quantity itself is still the same value. It's just a different way of describing it. Now, if we want to do a conversion, how do we do this? Well, first of all, it is clear that we need to have a conversion factor that gives me the relationship between the old unit and the unit I want to convert into. So for instance, if I want to convert from meters to centimeters or vice versa, I need to know in advance the conversion between meters and centimeters. Now, these things are found in any physics book that you will use. So there's no need to memorize any of these. Actually, I should point out there is never a need to memorize anything in physics. Memorization is absolutely useless in science, because in science we want to understand the principles behind what we do, and we want to learn how to apply these principles. We never want to memorize anything. So don't try to memorize on any of these conversion factors. Just look them up in a book, in a textbook, or online. So let's look at an example here. Let's start with a very simple example, just to show how this is done. And let's say that I have something that is 6 millimeters long, and I want to convert this into meters. Now again, I don't know what the conversion is, but I can look it up and I can find that 1 meter is equal to 1,000 millimeters. Now, I know that most of you watching this video right now are going to say, this is fairly easy. Just take 6 millimeters divided by 1,000 and you get the answer, because this is straightforward enough. If that's the case, good for you. But for the purpose of explaining how conversion works, just follow me on this. Now, the second line here is an equation. And you guys remember from algebra that you can do the same thing to both sides of an equation, and that will not change the value of the equation itself. So I look at my original number. It's in millimeters. I want to turn it into meters. The units that I have are in the numerator, because that's all I have. So if I want to cancel those millimeters, I need to multiply that 6 millimeters by something with millimeters in the denominator, so that they will cancel each other out. And I also need to have something with meters in the numerator, so that when I multiply, I get something at the end that is in meters. So what do I mean by that? I'm going to take my second equation and I'm going to write it as a ratio by dividing both sides by 1,000 millimeters. Now, what does this do? Well, on the left side, I just have a ratio of two quantities with different units. On the right, I have something divided by itself. This is 1. And by 1, I mean just a pure number, because the units themselves cancel as well. What this tells me that if I multiply something by the ratio on the left, it's the same as multiplying it by 1, because those are the same thing. So if I take 6 millimeters and I multiply by the ratio that I just constructed, see what happens here. I have the units here that cancel, and if you want, you can think of 6 as 6 over 1, if that helps you. And so what I'm left with here, it's a multiplication of two fractions, and the only unit left is the meters. So when I do this, I get 0.006 meters. And that works. I got my answer. Now your question might be, how do you know that you had to write the ratio with meters over millimeters and not the other way around? Well, it's mostly experience, but in this case it's simple enough. I know I want to cancel millimeters. Millimeters is in the numerator, so as I mentioned earlier, I'm going to write a ratio with the unit I want to get rid of in the denominator and the unit I want to end up with in the numerator. If I had my units in the denominator, then I will have to use the opposite ratio. So now let's just look at a slightly more difficult example here. Let's say that I have a compound unit. Say I have 1.34, and this time let's deal with the speed. I have something in kilometers per hour, and I want to convert this to whatever that number ends up being in meters per second. So now you see that I have two conversions to do. I have to change kilometers to meters and hours to second. Once again, I need the two conversion factors. So I know that 1 kilometer is equal to 1,000 meters. And I hope I don't need to tell you that 1 hour is equal to 3,600 seconds, though some students sometimes tell me that 1 hour is 120 seconds. Okay, so let's look at this number here. I have kilometers in the numerator, so in order to get rid of that, I have to do precisely what I did earlier. I can divide both sides here by kilometers. The left gives me 1. So multiplying by the ratio on the right is the same as multiplying by 1. So I have 1.34 kilometers per hour. Let's put parentheses just to be clear. And I have 1,000 meters divided by 1 kilometer. This will take care of the kilometers and meters. Now, for the hours, I have the opposite. The hours are in the denominator. So I need to use this ratio here on the right, but for that ratio, now I want to keep the hours in the numerator and the seconds in the denominator. So I'm going to divide by 3,600 seconds. Again, the right gives me 1. So when I write this, I get 1 hour divided by 3,600 seconds. And maybe let's use a different color now. And look, kilometers disappear, hours disappear. I'm left with meters and seconds. So what do I have to do here? I have to, if I want, I can divide by 1. I just have to multiply across, which means I multiply by 1,000 and divide by 3,600. And if you do that, I'll do the calculation for you. The number you get is 0.372, and your units are meters per second. And then you're done. So you see that even if you have to do more than one conversion, you can do it sequentially. You can just write all your conversion factors and multiply one by one the original number by these conversions. If for the first time it's easier for you to do them one at a time, that's fine. Just do the first conversion, get the first number, doing the second conversion, get the final answer. That's absolutely fine, because this, of course, takes practice. But for any number of conversions, this is how this is done. So to summarize, here's how we do the conversion. First, we find the conversion factor, and by find I mean you look it up in a textbook. You don't have to derive it yourself. You write it as a ratio that makes it equal to 1, and then you multiply the original quantity by the ratio and cancel the units. And that's all there is about physical quantities and unit conversions. So thank you for watching, and I hope you enjoyed the video.